Before we can get into the nuts and bolts about how to do automated testing well, we have to understand what it means to do testing well. And for that, we need a guiding principle. Hello, this is Code and Optimism, a show where we explore how to solve problems faster with software. And today, we're going to talk about the guiding principle of automated testing. We're going to do that in 5 steps. We're going to talk about the definition of automated testing. We're going to talk about automated testing as proof. We're going to talk about automated testing as metacode. And we're going to do a brief recap of the benefits we talked about last time. And all of that together, we're going to summarize and distill down to a guiding principle we can use going forward to guide us as we write tests. First, we're going to talk about the definition of automated testing. And relatively obviously, it is code testing code. But what does that mean specifically? It means that it is fully automated. It doesn't require any manual intervention. It means that we can run it over and over and over and over again as many times as we want, which both means that it's got to be reasonably fast. And it also can't do anything out in the world. It can't mutate our production database when it runs. And at the end of the day, it is testing code, which means in some sense we want to prove that our code is meeting the requirements. And so what does that mean for automated testing to be proof? And really it comes down to a bit of a philosophical question, like how do we actually know if our code meets requirements? How can we prove that to ourselves and how can we prove that to our stakeholders? Well, we write code to prove code. And there's a reason why automated testing is really the best possible way to prove code. And that is because, first of all, it is methodical rather than anecdotal. Many projects end up showing that they meet requirements by doing a demo, walking someone through it, showing it to a stakeholder. We all know that anecdotal evidence is not very good evidence because it's not thorough. It doesn't go through everything. It's not methodical. So when we're writing tests, we're of course not going to get 100% everything, but we do make a good effort to get everything that matters. It is also practical. So at the other end of the spectrum is a mathematical proof, which is airtight, 100% covers everything. And we don't want that either because that's really costly to near to impossible on most projects. So it is the both methodical and practical. Next, understanding that tests are, by their very nature, metacode. We are writing code about other code. And as such, we are embedding knowledge and information about our main system in our testing suite. And it's important to keep that in mind because we want to do this well. We want to embed knowledge about how the code works. We want to embed knowledge about why the code works. And we want to embed knowledge about what that code is for, all in the test suite. In an ideal world, your test suite should have all the essential knowledge that another developer would need to know about the system so that they can understand everything they need to know to work with it. Now, quick recap of last time's episode. We want to keep a view on the benefits we're trying to get out of this, because at the end of the day, we need to achieve these benefits for it to be worthwhile. Obviously, it's helping us find bugs, and very specifically finding bugs earlier rather than later, because bugs cost exponentially more the longer it takes before you find them. But it also significantly helps us write better code. We want to capture that benefit. It also can be the best possible documentation for other developers or even ourselves in the future when we're coming back and trying to remember this code base. Last, it helps us maintain high code velocity over the long term. And to me, that's the most important benefit of automated testing because nothing is worse than coming into someone else's code base or even your own code base from a year ago and trying to make a change and being terrified to do it because it might break things and you have no idea unless you have a good test suite. So now with all of that together, we now have the ability to formulate a guiding principle. And here is the guiding principle from my perspective. It is to improve our ability to reliably meet requirements. Let's break that apart. Improving our ability means that without automated tests, we're not going to do as good as we will with automated tests at reliably meeting requirements. Right off the bat, that's what we got to be doing. But it means more than just with or without automated tests. It means a sense of continually improving. We're going to continually try to make our test suite better, which might mean deleting and removing tests as well as adding tests or reorganizing tests or refactoring the test suite. We're going to work to continually improve our ability to meet these requirements. It also means reliably, and reliably means more than one thing. Reliably certainly means consistently. We want to make sure that we can consistently meet our requirements. That's what we think of when we say reliably, but it also has got to mean quickly. We can't start meeting requirements slower and slower. That is also would be unreliable. So quickly and consistently. And last, we have to be able to meet requirements in the grand scheme of things. So we have to be able to express requirements in our tests. We have to have some way to be able to take the concept of a requirement and make it concrete. Then in our main code, when we solve for that requirement, we have to then be able to verify that this expression of the requirement is actually embodied in the code in the implementation. So we have to be able to verify the requirements. That is the guiding principle of automated testing. And in summary, we took all of these things together to form that principle. And that principle should in some way capture each and every one of those. It is code testing code. It is code proving code, that is the meet requirements. It is code about code, which is really about our ability to reliably meet the requirements. That documentation aspect comes into that reliability. It also is going to deliver these key benefits. It's going to help us find bugs earlier. It's going to help us write better code. It's going to help us have the best doc possible for developers, and it's going to help us maintain high code velocity. All of these things get boiled down to this guiding principle: improve our ability to meet requirements. As we wrap up here, why do we have a guiding principle? We have a guiding principle because it is what we can go to when we sit down as a team and make decisions about what we're going to do with automated testing week on week. We're going to say, should we add more tests? Well, does it actually improve our ability to reliably, in the sense of quickly and consistently, meet requirements? Test suites get too big. They do. We all know this. We need to be able to have a way of saying, have we done too much? We're going to keep coming back to this phrase as a way of resolving arguments and a way of us all calibrating on the same true north. So with that, we're going to next time dive into actually some concrete aspects of writing automated testing. We're going to talk about what I call modular testing, and why I think that the traditional unit, integration, and end-to-end testing really fail to live up to our guiding principle. I think these ideas have come down from physical engineering, and they don't fully translate well to software engineering. That's next time, but for right now, I'll say thank you so much for spending your valuable time with me. And remember, all problems are solvable with enough knowledge.